We have finally completed our chicken aquaponics system working prototype, and I'm excited to show you around. So let's get started. We've completed the build with items you can find in most hardware stores, and more specifically, we've used items that are readily available in Asia, because this is where we live and work. The chicken aquaponics processing system is comprised of two major components: the waste capturing station and the biological reactor. The waste capturing station houses overnight hens in a coop suspended over two 200-liter catchments filled with water. The catchments have pumps that are designed to break down the waste into small particulate matter. The wastewater is pumped into the second major component of the system, the biological reactor. The biological reactor uses aerobic bacteria to convert chicken manure particulates into nutrient-rich solution that is intended to be safe and suitable for growing consumable garden products. The overall goal of this project is to make chicken manure safe and suitable for use in hydroponic gardening systems and to make the systems available to the poor people living in this region of the world. In previous videos, we have detailed the construction of the production roost and roost rack. You can review those videos by clicking the links we have provided at the end of this video, or by going to chickenaquaponics.com for a complete list. Inside the catchments, we've installed two 12-volt DC pumps. We installed DC pumps so that we can switch to solar power at any time. The pumps push the wastewater into 3/4-inch PVC tubing that travels overhead to the biological reactor. The bioreactor has 4 tubes. The first tube is hollow and is used strictly for settling heavy matter to the bottom, where it can be flushed out at an appropriate time. The second, third, and fourth tube contain 60,000 6mm hollow polypropylene beads. As the tubes are filled with wastewater, the beads are forced to the top, requiring the circulating water to pass through them, forcing the biological reaction that feeds the aerobic bacteria living on the surface of the beads. When the wastewater has completed its cycle through the biotubes, it is directed back to the waste capturing system for reprocessing. The wastewater is recirculated until it reaches optimum levels of macro and micronutrients, as well as removing harmful elements. The bacterial digestion process is aided by dissolved oxygen in the wastewater. We accomplish this by including a 12-volt DC air pump, pumping air into an air diffusing stone, and placing that stone and air system at the bottom of the digestion tube. Over time, the aerobic bacteria will form a film over the surface of the beads. If this biological matter is not occasionally cleared, the tubes will clog. The beads are cleaned by opening an aspirating valve located partway up the biotube. The aspirating tube has a check valve to prevent the water exiting at the aspiration point, even when the valve is open. The wastewater is purged from the tube by opening a dump valve located at the tube's lowest point. As wastewater exits, air is drawn through the aspirating tube, creating a violent reaction that shakes and collides the beads together, clearing them of the biomass that accumulated on their surface and causing the biomass to exit the system as a waste stream. So there's a brief overview of what we've created. We plan to make a detailed step-by-step video of the system construction. We will be making it available for a limited time on our website for those people who sign up before we finish the final release. We do this because we would appreciate you reviewing our work and offering suggestions for its improvement. We plan to have the video available sometime at the beginning of 2020, but it will be available for free for a limited time, so be sure to sign up right away. Also, subscribe to our YouTube channel so that you'll be alerted to future video updates. Thank you for your helpful participation, and we look forward to hearing your questions and advice.